I'm going to begin. So thank you all, everybody, for coming to our seminar series this morning in Pakistan, this evening in North America. And this is the ongoing Siwalik seminar series. We're now in week 16 or 17, I believe. And before I introduce this evening's speaker, first I'll say myself, I'm Bob Reynolds. I'm living in Denver, Colorado. And it's been my great pleasure to work with everybody on having this seminar come together. Next week, we have Turi Serling from the University of Utah. And Turi's going to talk about his work on isotopes, and it'll complement some of the work that was reported on earlier by Kay Berensmeyer and Catherine Badgley and others. The following week, we have Shahid Iqbal, who is going to be speaking to us about the Peshawar Basin sediments, and he's from Quaid-i-Azam University. The week after that, we have Yani Naiman, and she will probably be speaking about regional structure and tectonics and deformation of the Siwaliks. And then we've got Adbay Junkar in July, and then tentatively Imran Khan may be our final speaker for the series before our summer break, and that'll be about the 14th of July. We're anticipating that we'll probably have a summer break, and then we might see if we restart the seminar series in the fall. That's still a little bit under construction. This evening, or this morning, it's my great pleasure to introduce Dr. MonaLisa, who is from the Department of Earth Sciences at Quaid-i-Azam University in Islamabad. And she has had a remarkable career. She's won the gold medal in Earth Sciences from the Pakistan Academy of Sciences, and she has done research on seismology and seismic hazards, collaborating with people from both the United States, from Italy, from the United Kingdom, from Germany, and Italy, Iran, and other places. So a remarkable achievement, one of great collaboration and international working together. And she's coming to us from Quaid-i-Azam University. And I think with no other comments, I'll just introduce MonaLisa. So thank you very much for joining us, and we look forward to your talk.
Thank you very much. I'm really very grateful to all of you, and good morning and assalamu alaikum to everyone. I'm sorry I could not put name of Professor Kasim Jan in this presentation, although this whole work which I'm presenting, this is actually a collaborative work which I and Professor Kasim Jan have done, and I didn't know that this work was presented somewhere else, so I just skip his name. But no doubt that is a great honor for me that I and Dr. Kasimjan have worked together, and we did a lot related to the seismicity of Pakistan, and we addressed especially northwest Himalayan fold and thrust belt, which is which is causing a great source of major earthquakes in Pakistan, major and moderate size of earthquakes in Pakistan. So uh, first of first I would like to thank Professor Kasimjan that he helped me a lot to understand this earthquake sites, and we work together, and still we are working together, and a major part of this work is a collective work of me and Kasimjan. So now we know that we are living on a position where three very active plates are colliding, Indian, Eurasian, and Arabian plate. And at the same time, we have on the southwestern part is bounded by German transform boundary. So basically, this in this slide, I'm trying to show that uh, uh, Pakistan is surrounded by not only three convergent boundaries, but at the same time there is another major transform boundary, which is German transform boundary, and due to which we have proposed and we have find out that we are experiencing translational tectonic. That is, we are having the more active strike slip faults as compared to thrust and reverse faults, which I think some of the geologists in Pakistan and abroad, they worked a lot in Northwest Himalayan. But as a seismologist, our research shows that even in Northwest Himalayas, the role of translational tectonic is quite active. We are experiencing the more activation of strike slip fault as compared to thrust or reverse fault. But definitely there exists some blind faults as well, like Indus Kohistan seismic zone and Hazara Lord seismic zone and Tarbila seismic zone, which are lying at a very shallow depth. And in October 2005, when that Kashmir earthquake occurred, basically our research, uh, which we did, and definitely I must confess that Corrigan State University, they helped us a lot, and uh, uh, Bob Yeats and Andrew and John, we all work together to understand the Northwest Himalayan tectonics and to understand the kinematics of Kashmir earthquake especially. And the most important thing is that in this particular part of Pakistan and in this particular part of Himalayas is that uh, uh, Nanga Parbat syntaxes, as Kasmijan indicated in his book and in his research, is that Nanga Parbat syntaxes and Himalayas, they are continuously uplifting, and their rate of uplifting is quite high, and it is rising, and rise of and uplifting of Himalayas can be observed by seismological data as well, because this slide is only, this has been taken from one of the published paper of Roger Wilhelm, but and this is only showing these yellow dots. These are only showing the distribution of major earthquakes whose magnitudes are larger, but further slides will indicate that uh, this area is highly congested by moderate size, and even micro seismicity is very high in this area. But this is a generalized picture which is correlating the major earthquake and the tectonic plate boundaries in within and surround Pakistan. Um, I think you don't mind about my voice because I just woke up and started my presentation. Um, so you have to bear my voice. Now, this slide is showing basically, once again, this has been taken from one of the published paper of Pelham, and actually, Andrew has also shown in his presentation the distribution of major earthquakes, which were considered as disaster earthquakes along the Himalayan belt, and this continuation and this sequence and the trend of these major earthquakes is confirming the fact that uh, Himalayan ranges are quite active, and um, even in past they are causing major earthquakes. Um, Kashmir earthquake also occurred on Himalayan ranges, and the coming slides will show that a part of Northwest Himalayan fold and thrust belt is quite active, and we are still believing that this Kashmir earthquake has not released so much energy in recent past. We are believing that in near future there must be a disaster, and there might be a major earthquake with magnitude even higher than 8, which can occur in this specific part of Himalayas, which lies in northwest uh, northwest of Pakistan. So there are two things which are quite significant from this slide. One is the trend of major earthquakes which occurred on Himalayan ranges, and that is they are following the sequence, and they are following the trend of Himalayan ranges, which show the activeness of these ranges. And the second thing is the size of those earthquakes. The sizes of these earthquakes are quite high. Means size means magnitude. They all earthquakes are major uh, earthquakes, not moderate size or minor earthquakes. They are all disasters, and Kashmir earthquake was one of those earthquakes which occurred in which occurred along this sequence. And we are trying to find out the reoccurrence of northwest Himalayan fold and thrust belt, that uh, what would be the magnitude, and uh, when can it be happen using probabilistic seismic hazard assessment. And in this study, for the very first time in Pakistan, Monte Carlo simulation have been utilized. Monte Carlo simulation is a technique which is uh, different from the conventional probabilistic seismic hazard technique, which has been adopted all over the country. And I myself have worked a lot using this conventional cornell probabilistic technique. But most recently, I have worked together with Kasim Jan Saab, and uh, this technique has been introduced, and this work has been submitted into different journals and under review, and soon the results will be open for all of us. Now, once again, as I said earlier, that uh, these two pictures, diagrams, they are showing actually the blockage of earthquake stresses, which are which are lying along the Himalayan boundary and Himalayan ranges. And if we see the part which is lying in northwest Himalayan, then we can easily see that um, there is Willem and his co-worker also indicated the occurrence of future probable major earthquake with a magnitude greater than 8 in this area. So uh, actually, uh, uh, we cannot say it with 100% confirmation, as earthquake science is that sort of science which is both experimental and theoretical. In this work, I use both approaches: theoretical, which is based upon the computational modeling of the future probabilistic approach, that is the Monte Carlo, and computational, along with computational or theoretical, we have done some field work in some parts of this area. And the picture, I will show the picture which show the active faults in some parts of the Himalayas. Um, Overall, the conclusion is the same, that Willem indication in 2001. We are in 2021, but we are still confessing that, and we are still confirming that blockage of stresses along the Himalayan ranges is still in operation, and that can be the source of major earthquake in near future. This is an overview of seismicity along with the Himalayan range, and the dots, blue dots, they are indicating the distribution of the earthquakes of magnitude, which are starting from 4 and 4 and above earthquake magnitudes. Their distribution is plotted here, and this is again showing the relationship and the sequence and the trend of Himalayan ranges and the seismicity within this Himalayan ranges trend and along and in the surrounding part of the area. Uh, some focal mechanism solutions have also been plotted in this map, and as I said earlier, that focal mechanism solution, as everybody knows, they indicate the trend, and uh, they indicate the source and the type and the uh, uh, nature of the faults which are active. So in that case, again we are experiencing strike slip faults along with the thrust and reverse fault. um, but strike slip activation, strike slip faults, as you can see in the upper part of the slide, there are two very prominent strike slip focal mechanism solution. So it is indicating that strike slip tectonic is more in operational as compared to thrust or reverse. Now this is an overview. I'm just uh, I have talked much about the plates, boundaries, and Himalayan tectonic, but the slide is showing actually the earthquakes locations with magnitude greater than 5 in Pakistan, and this data is covering the duration of 1900 to 2017. There are a few things which must be noted, that if we look at the legend, which is indicating the depth of origin of the earthquake, is that majority of the earthquakes which are labeling with the purple color, they are of very shallow in depth, that is less than 33 kilometer. This data shows that we are not only experiencing higher frequency earthquakes, mean frequency of occurring of earthquakes is quite high, but at the same time we are also experiencing very shallow level depth earthquake in that region. Most of the Pakistan, you can see that not only in northwest Himalayan fold and thrust belt, all over the country the situation is the same, and we are having the very shallow, less than 33 kilometer earthquakes. They are more in numbers. They are more, and not only more in number, but they are frequently occurring within the country, all over the country. So uh, uh, my work is more related to Northwest Himalayan fold and thrust, but I have worked. I and Kasim Saab have published a paper on Ziyarat Balochistan earthquake as well, and in Natural Hazard, which published in Natural Hazard, in which we introduced the concept of um, duplet earthquakes. And that concept has also been introduced for the very first time in Pakistan. Duplet earthquakes concept is very common in those areas of uh, earth where the active tectonic uh, where the tectonic is active not only on the surface, but there are number of blind faults, and sometime if one earthquake occur, then soon after the similar fault uh, mm, uh, a similar fault, which is the causative fault of that earthquake. Um, uh, the second earthquake occurred, which is not related to that causative fault. So this is the concept of duplet, and in surrounding region like in Iran and in India, many researchers like Mehdi Zayer and in Iran, Professor Kayal, they have introduced the concept of duplet and triplet, even triplet. They have introduced. So, Ziyarat earthquake, we believe that which occurred in southwestern part of Balochistan, and we believe that that earthquake was actually the duplet earthquake. So this was another new concept which we introduced, and after that we are now working on Dilbadin earthquake, um, which also occurred in Balochistan, and that magnitude, a high magnitude earthquake occurred in, I guess, in um, Kasmian, if you can correct me, that earthquake occurred in 2009, Dalbadin earthquake.
Yeah.
Yeah. So this earthquake was of magnitude 7.1 in moment magnitude, which is quite high in magnitude, but the devastation caused by this earthquake was quite low due to less population in that area. But again, the occurrence of such a large magnitude earthquake is indicative the active tectonic nature, not only in northwest Himalayan fold and thrust belt, but also in Suleiman Kirthar fold and thrust belt, and even in offshore area near Karachi, where Karachi is situated. Even here we are experimenting. I can say that experimenting because uh, near offshore there are less seismic stations, so there is lacking of data as compared to other part of Pakistan. So we are experimenting this Carlo simulation technique in that area too. Um, so the fault map, active fault map, which we prepared on the basis of field data and seismological earthquake data distribution, and along with the focal mechanism solutions. So correlation of all these three parameters, we just indicated the active faults, and we declared that there are 45 active faults in northwest Himalayan fold and thrust belt. um, I think the declaration of faults to active active faults is just based upon the seismicity data, second focal mechanism solution, and some field studies. But definitely, Andrew and his team, they have done a lot related to the geological field work, especially in uh, Kalabag area. So we have incorporated his work, his and his team's work as well. But there is one thing is lacking in declaration of active faults, is that we do not have any paleoseismological observation in Pakistan. Pakistan is lacking in paleoseismological studies, for which, uh, as Andrew said in his presentation, that we have submitted various projects, and then try to cover all these aspects which are related to active tectonic and new tectonic of the Pakistan. But unfortunately, we could not get any funding. So uh, mm, paleoseismology, which is a very important part of the seismological work, especially in those areas where tectonic is very active, like in Himalayan ranges. We need to do the paleoseismological work. So in this slide, only um, those faults are indicated, which are showing activity on the basis of recent seismicity, recent earthquakes, and fault plane solutions or focal mechanism solutions. Now, this earthquake occurred in Tajikistan, although, but in Feb 2021. But I just put this slide just to show that Pakistan not only is experiencing with those earthquakes whose epicenters are actually lying within the Pakistan, but Pakistan is also experiencing felt earthquakes. Felt earthquakes are those earthquakes whose epicenters are not lying within that particular location, but they're shaking and they can shake the large area, surrounding area. So this earthquake, I have just put this slide just to show the felt earthquake which occurred in Tajikistan, but in Pakistan, especially even Islamabad, its shaking was felt, heavily felt, and people were very um, frightened, and they just came out from houses when this earthquake occurred. So I'm just pointing out that we are not only have the fear of earthquakes whose epicenters are actually lying within the political boundary of Pakistan, but also we are having the threat of felt earthquakes which are occurring in nearby regions like in Afghanistan and in Hindu Kush area and in Nepal and in Iran and India. So if any earthquake which have the major magnitude that is greater than 7 or 8, if it occurs in nearby region, then definitely this earthquake can cause also devastation in Pakistan too. So this slide is just an example that we have to be careful, and we have to study the belt earthquakes effects as well, which are occurring frequently in the surrounding regions of Pakistan. Now this is our uh, original data presentation, which we compiled and published in different literature as well. But this diagram has been updated. Initially, a catalog was developed, which was comprising the data duration of 1905 to 2007, and then it was updated using the local and international agencies or international observatories like USGS and ISC and ARIS data. So we updated this catalog, and now a new catalog is formulated, and this new catalog is showing the distribution of seismicity in this diagram. Now this is a picture of sample picture of the analog data which we usually obtained from some seismometer or accelerometer. Actually, the purpose of showing this slide is just to show the audience that how earthquake is recorded on any seismometer or accelerometer, and um, our observations and our interpretations, our work, seismologist work, is highly dependent upon the data accuracy. uh, what sort of seismological data is used is actually the base of accuracy of any seismological work. So we seismologists are basically highly dependent upon the accurate source of data and accurate data incorporation in any work, especially in probabilistic or statistical approach. If we are trying to apply any probabilistic or statistical approach to find out the occurrence of major earthquakes or minor earthquakes or any sort of earthquakes in specific area, then we need to have a precise and most accurate data source. Otherwise, uh, uh, we, whatever technique we use, if it is not based on the accurate data, the technique is not um, useful. It's just a labor work, which I'm sorry to say some of the Pakistani researchers are doing like this. They don't look at the accuracy of database. They just apply the technique and show the result, and then they publish. But I must say that database and accuracy of database is very important. So this slide is just giving the sample of an analog data which is obtained from one seismometer, and this is actually showing the analog form of northern Pakistan Kashmir earthquake, which occurred in 8 October 2005. Now, in this slide, we are just trying to show the magnitude level, magnitude distribution of earthquakes in contouring form. Although there is some debate, and I have been asked by several, whenever I present this slide, some person asked me that how is it possible that magnitude is presented in contour form, because magnitude is a constant and static number which cannot be changed. It cannot be changed. It is a static and definite number which shows the size of an earthquake. But definitely different magnitude scale, they show a slight variation in number, like in ms type of magnitude. If an earthquake had ms magnitude showing 7.1, then in moment magnitude, this earthquake can be have 7.2. So different magnitude scales shows a similar earthquake, different values, but these values definitely don't drastically change. Like if 7.1 ms magnitude, then it cannot be a 6.2 in MW. So there is a smaller change or smaller difference due to different scale. So this slide is showing the distribution of magnitude all over the northwest Himalayan fold and thrust belt, and uh, it is clearly indicating that although, as I said, that database is very important, and we have established catalog, and this diagram is actually based upon that catalog data which we established, and strangely, it is indicating the more um occurrence of magnitude earthquakes, which those earthquakes which are having magnitude less than 4.5 moment magnitude. However, the frequency of although the frequency of lower magnitude is quite high, but as we know that and as I indicated that we are having very active blind detachment and detachment zones, and especially Indus-Khoisan seismic zone and Hazara Lower seismic zone and surveillance seismic zone. All these zones, these are quite active, and I believe that, I truly believe that due to the presence of these blind zones, lower magnitude earthquake frequency is quite high. Uh, and this is one interpretation um, based upon the catalog which we established. Now this slide is showing the correlation of focal mechanism solution which we selected for some of the earthquakes. Catalog is comprising of more than 5,000 earthquakes, but due to some specific reasons that non-availability of specific parameters which are necessary for carrying out fault-free solutions. We just plotted and we just formulated some of the available parameters, focal mechanism solutions, and as you can see that um, there are three observations which we made by compiling fault-free solutions of some of the available earthquake parameter data. One is that we have north-northwest, south-southwest, left lateral strike slip faults. They are more active, but they are having steep dip. This is one observation which is based upon the fault-free solution, and that left lateral strike slip fault in north-northwest direction. They are causing they are more in number. Then northwest southwest and north-northeast southwest trend with steep to shallow dipping thrust reverse faults. They are causing some of the earthquakes, and but the result is the same, that we believe that transpositional tectonic is more in the area as compared to uh, uh, thrusting or transpositional tectonic. Um, we can see that there are these red colors. They are indicating actually red color lines. They are indicating the strike slip faults which are present in the area. Like here we in Naga Parbat, we are um, near. Um, we are having Thakot fault, and here in Kashmir, Hazar Kashmir syntaxis, we are having Jhelum fault, which is a major strike slip fault as declared by Mirza Shahid Beg Saab from AGK. They have worked a lot, and then again there is another fault which Bob Ahmed Hussain and I have published together, and that is the Balaclava Fault. um, uh, Punjab University named it Muzaffarabad fault, and these faults are actually the thrust fault, Muzaffarabad or Balaclava fault, which was actually the source or the cause of or the surface impression of interscoism seismic zone, as we declared it our research, published research. But at the same time, we also observed that this fault is carrying the strike slip component, which is left lateral strike slip component. And on surface, we are having a left lateral Jhelum fault. So we need to correlate, we need to have some more observation, or we need to have some more data in order to correlate, or in order to confirm this fact that strike slip component or strike slip fault, they are playing more active role. And in salt range area, we have color Kahar fault, and there are some earthquakes whose fault plane solutions they are showing. There are exactly lying on this fault, and this fault has been mapped by various workers. But our research shows that this color Kahar fault is a quite active fault, although salt range due to presence of salt, earthquake activity is less in that specific area, because the salt is playing a role of playing damping role. But at the same time, we observe that there are large number of smaller magnitude earthquakes which are occurring along this Kalar Kahar fault. Then comes the Calabar fault. Calabar fault, once again, is a strike slip fault, and it is right lateral strike slip fault, but it is its northern portion is divisible into 2 to 3 segments, which various workers like Andrew and some Pakistani researchers like Dr. Sajjad, they declared a thrust and reverse branches, or thrust or reverse behavior in the northern part of this Calabar fault. So Calabar fault at one time is right lateral strike slip fault, but its northern part is its northern part carrying thrust, reverse, and normal um, normal normal thrusting, normal faults also. And if we go to the um, uh, transcendus ranges, like in near Marvat or Betani ranges, then we see that in Surgar or Betani or Kisor thrust, they have also carrying some strike slip component, and there is one strike slip fault which is a piezo fault. And our work also show the location of fault plane solutions, the locations of earthquakes. These two things indicate that piezo fault, which is a right lateral strike slip fault, is quite active. So this overall diagram is showing the behavior of combination of strike slip as well as the thrust and reverse tectonic. And once again, it is indicating that strike slip faulting is also very active in this specific part. Um, Everybody is familiar with this picture. This is actually showing the intensity of that Kashmir earthquake, and actually the intensity, if we plot intensity, or um, um, if we plot or formulate isoseismal map, which is intensity map, then it simply indicate the damage and destruction trend. And on the basis of this damage and destruction trend, we can say that which is the causative fault, and what is the trend of that causative fault. So actually, this intensity survey or intensity or isoseismal map help us to find out the trend and trend and direction of the causative fault. So this on the right side, um, this 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 is indicated by some Indian geologist, and on the left side, this is our work, which is showing the trend of isoseismal um, uh, isoseismal activity, and which is caused by Kashmir earthquake. This slide has been shown by various workers, and as I said earlier, that Indus-Khoisan seismic zone is quite active in northwest Himalayan fold and thrust belt, and I must say that in future, um, surface faults can be active, but these major blind zones, Indus-Khoisan seismic zone and Hazara Lode seismic zone especially, uh, they can cause a major disaster in this specific area. Uh, we need to find out. We need to have more data related with these two blind zones, especially because in this area, um, Kashmir, Azad Kashmir University, Peshawar University, and Punjab University, they have worked a lot. Geologists, they have published a lot of work related to this Hazara Kashmir syntaxis area, but none of them, they have indicated the active characteristic nature of these two blind zones. Although Bob Gates from Oregon and Ahmed Hussain, they have worked, and they have Bob even with some Indian colleague. I've just gone through one of his paper, which he sent to me, and in which he just correlated geophysical data, seismic exploration data, seismological data, and fieldwork. And on the basis of all these field studies, geophysical data and seismological data, he and that Indian worker, they have indicated the active characteristic nature of Indus-Khoisan seismic zone, and the role of Decolma near Salt Range, and they believe that there is going to be another active deformational front which is lying near, which is covering the area near salt range. So that paper is very interesting, and I just see only that paper, which is indicating the active characteristic nature of these two blind zones, Indus-Khoisan seismic zone and Hazar Lord seismic zone. Um, so once again, this slide is slightly different to some extent as compared to the previous slide. In this slide, seismicity data is plotted, and the trend, the seismicity data, that trend is trying to correlate with that blind zone of Indus-Khoisan seismic zone. And as I said, that Indus-Khoisan seismic zone is a very, very broader, uh, excuse me, very broad and very large zone, but at the same time it is lying at a very shallow depth, means 10 to 12 kilometer. So this seismicity data is actually indicating the depth of that blind zone, and this is covering the area of Tarbela even, and from Tarbela, starting from Tarbela to Islamabad, we are having Hazara Lord seismic zone, which is lying parallel to that Indus-Khoisan seismic zone. And then after Islamabad, in northern Potwar deformed zone, from northern Potwar deformed zone to Salt Range, we are having um, um, triangle zone, which has been indicated by Jadun in one of his work. So all these zones are very active, although they are blind, but they are playing a very important role, not only in the tectonic and seismicity of the area, but especially in the northern Potwar deformed zone. Um, our recent study shows that injection of fluid and due to industrial work, geophysical surveys, they are triggering the seismicity level in Potwar region especially. Um, I have just submitted that paper too, in which I have correlated the geophysical work, uh, uh, geophysical work which has been carried out in Potwar area, that is disturbing or activating the existing faults, either they are blind faults or flower structures or whatever the kinematics and the blind faults or the surface faults. These faults, they are actually they have now the increased level of seismicity as compared to previously obtained data. Now the seismicity is increasing. We believe that mm, due to high geophysical surveys and injection of fluid, well drilling, these are causing the activation of some of the faults in Potwar area. Now, I think this slide can be described by Kasimjan and Andrew rather than I, because I'm not a geologist. But actually, this is showing the location of the Balaclava Fault aerial view. This is an aerial photograph, and this aerial diagram or aerial photograph is actually indicating the location of Balaclava Fault, which was the cause of Kashmir earthquake. Once again, I think Kasimjan can describe it very well. As I said, I'm not a geologist, but this field mapping, this area is not the Kashmir area, but it is the area where Riyasi thrust is lying. And one of my MPhil student, he did his MPhil research on Riyasi thrust, and using the integrated approach of geophysical data and seismological data and geological field work. So he just visited that area, and he did some geological field work, and he just tried to map the Riasi thrust. Uh, it must be noted that the Mangla Dam is located quite close to that Riasi thrust, and we believe that Riasi thrust is a very active thrust, and which can cause a major earthquake in near future. So my and my MPhil student, we have just interpreted that we need to have some more field observations and correlation of latest seismological data, like putting some installing some seismometers there, and to get data of 2 to 3 months, and then we can correlate this latest data, um, uh, which is comprising of 2 to 3 months. Uh, we can correlate it with the geological field work, and then we then confirm this our interpretation, which my student did in his MPhil work. Um, so this is another field study which he did, and this is also indicating this is one section which he covered uh, of Riasi thrust, and which is passing near Mangla, and he just visited it and just mapped and tried to find out the active characteristic of that Riasi thrust. Another another picture of geological fieldwork. Now this diagram is very important because this diagram is showing the collective seismicity, fault plane solution, active faults, their nature, their trend, and actually in this diagram we are trying to correlate all these three important parameters with each other, like drawing or plotting the earthquake data on this northwest Himalayan fold and thrust belt is showing the distribution and the trend of seismicity. Like if we see near um, in Kagan, in area which is near Kagan, then we are having a cluster of earthquakes. So, but if we go to salt range, then we are having dispersed or less a number of distribution of earthquakes. So, just by plotting earthquake data on any map, it just shows the seismicity trend of that specific area. And definitely, as we know that earthquakes are caused by faults, so if there are large number of clustering of earthquakes and they are following some specific trend, and even though geologists or any other scientists, they have not mapped any fault in that area, but earthquake cluster is showing that there is some activity. So we can map, or we can trace, or we can draw down the faults on the basis of this distribution of earthquakes. So important thing is that I must say that we must have the correct and reliable catalog on the basis of which we can interpret, or we can find out the unmapped fault as well. So the second thing is once again the fault plane solutions. Fault plane solution is a technique which is a very useful technique, and unfortunately in Pakistan this technique has not been utilized by most of the workers, and they do some work. They did some work related to geology, and but fault plane solution only we have carried out, and we need to have more fault plane solutions, because fault plane solution is the only technique which on the basis of which we find out not only the causative fault nature, that is what kind of fault is it, either it is strike slip or thrust or reverse. But we can also find out the trend of that fault, that is strike and dip and other parameters which cannot be mapped geologically. So if due to as we know that due to this COVID and then due to some strategic reasons and in some areas field work, geologists cannot do some field work. So in that case, if we have fault plane solution data and we have fault plane solutions, then we can easily map the blind faults and show the active characteristic nature of surface faults as well. So this is a very good tool, and this is a very important tool which we can use in an area, especially Pakistan, where due to political constraints, field work is not permitted. But if we have the earthquake data and we have formulated the fault plane solution, then we can indicate or map the fault, map the active fault there. Once again, another closer view of the area near Islamabad. Islamabad being the capital of Pakistan. Islamabad is capital of Pakistan, but unfortunately, Islamabad is lying on a very active tectonic domain, and there are a number of active faults which are passing very closely to Islamabad, and MPT and MPT's plays like Margla thrust, Thandiani thrust, Nathiagali thrust, they all are causing, they all can cause a severe damage to Islamabad. Most recently, we have established our Maya and Kasimjan, one of project which was funded by HEC, and through this project, I have established a lab in Quaid-i-Azam University, and this lab, the main aim of this lab is comprising of both accelerometers and seismometers, and this is the first lab in Pakistan on university level which have 8 accelerometers and 4 seismometers, and the basic aim of and they are short period uh, seismometers. We are not having the broadband or very broadband seismic stations in this lab. We have only short period, or they are covering the area of Pakistan only. And the purpose of establishing this lab is to prepare ourselves to have a more reliable data, especially for Islamabad and its surrounding. And uh, recently, I have used the data of 6 months data of this lab, and published a paper in an international journal in which I have used the data of uh, this lab, which is indicating that Islamabad is experiencing high frequency micro level of earthquakes, and I did a fault plane solution of those earthquakes as well, and I can share these results of this publication as well with the audience if they want, and they can just send me an email, and I can share the observations which are made, uh, which are based upon the real-time data which is obtained this recently developed lab in Quaid-i-Azam University. Um, I'm going to just skip this because I have already talked much about this transpirational tectonic, and this is actually showing two of the major earthquakes which occurred in northwest Himalayan fold and thrust belt, and their their fault pin solutions, which I have already discussed. Now this is um, uh, in this map. I have just tried to place all the active faults on the satellite map. As I said earlier, that with the passage of time, geological field work in Pakistan is becoming difficult. So we have to we have to incorporate more different approaches in order to find out uh, the seismic activity and active characteristics of existing fault or even fault mapping. So in this map, I just try to place or correlate the active faults which I indicated in the previous slides on a satellite image, just to indicate that satellite images, um, by having satellite images, we can have a better picture or more reliable results of the location of active faults in specific area. So this slide is only showing that if we do not have the access of physical geological fieldwork, then we can at least have, if we have satellite image, then we can plot or identify uh, the faults in any region. Now this is once again a part of Balaclava Fault and Sulphur Range, and the correlation of earthquakes and their focal mechanism solution. You can see that majority of focal mechanism solution, they are strike slip once again, and this is specifically for the area near Calabar Fault, which is indicating that right lateral strike slip nature of Calabar Fault is quite in seismotectonic in that particular area. Now this is this has been published soon after the occurrence of Kashmir earthquake, that is in 2005. When Kashmir earthquake occurred, then in 2007, I and Kasim and some other researcher from NISPAC and some other institutes, we then developed this seismotectonic zonation map of Pakistan. That map then updated, and using this Monte Carlo simulation approach. This is a summary of this approach, and anyone can have this the procedure of this approach from internet or from any book. I just summarize this approach on this slide, so I'm not going to waste time on just reading this the procedure of Monte Carlo simulation procedure. Anyone can see this procedure from any book or any literature or from internet. One thing I just want to indicate that this technique is not a conventional probabilistic seismic hazard technique, which is being adopted in Pakistan by like Cornell and McGuire and Frankel. They have adopted conventional formulated conventional probabilistic seismic hazard, and which is being adopted in Pakistan. But now we have developed probabilistic seismic hazard map of Pakistan using this Monte Carlo simulation technique. Once again, the procedure. On the basis of this sorry on the basis of Monte Carlo simulation, we have updated the seismotectonic zonation and seismic hazard zonation of northwest Himalayan fold and thrust belt. And as you can see that there are several different colors which are indicating the different zones in which now northwest Himalayan fold and thrust belt is divided, and this is where H is written. H is showing high hazard, and M is showing medium hazard, while L is showing the low hazard. So this diagram is showing the probabilistic seismic hazard assessment using Monte Carlo simulation, and on the basis of which the previous seismotectonic map, which I have shown in the previous slide, which was established in 2007, that has been updated, and on the basis of newly adopted approach, and by the incorporation of Quaid-i-Azam University laboratory, we can see that seismic zonation, this updated seismic zonation, they are showing that Islamabad is lying in a high hazard zone, which was not declared by previous worker. They even ourselves, we have also declared Islamabad in a moderate zone, but now this latest data, which is also based upon Quaid-i-Azam University laboratory data, so this is showing that now Islamabad is lying in high hazard zone. And at the same time, if we look at the some part of salt range near Kalar Kahar, even this part is lying in high hazard area. So we can say that that we have updated or upgraded these informations, and on the basis of this MC approach, and MC approach is very useful, and Julian Bomber from Imperial College, he helped me in order to understand this approach, and I have he has just sent me uh, one or two of his paper, which he did using MC approach, Monte Carlo approach, for other parts of world, and uh, uh, with his collaboration and with his guidance, I just tried this approach for Northwest Himalayan fold and thrust belt. So this is showing the updated hazard map of Northwest Himalayan fold and thrust belt. Then this work has been done for the specifically for Hazara Kashmir syntaxes, and since there are large number of parameters are involved, and I think I need one full day to explain all the parameters and their procedures and the things. I'm just showing the results of our work which we done for Northwest Himalayan fold and thrust belt only, and but we did some work in southwestern part of Pakistan also. So this is showing the hazard zonation map based upon that approach, and they are indicating zone 1, zone 2A, and zone 2B, and zone 3, and zone 4. And I must say that in this work, NESWAC is also involved, because uh, they um, they they just contacted me and hired me as a consultant to prepare hazard zonation map for that particular area. So I did this work for them, but definitely this work is also going to publish very soon. Um, this now these are the results of our work. Um, the faults, their nature, their expected rupture length, and different attenuation equations, which has been adopted, and they show the maximum potential or maximum credible earthquake or of the active faults, especially near Islamabad area. Once again, their computed acceleration, peak ground accelerations, we all know that probabilistic approach or deterministic approach or seismic hazard is highly based upon the peak ground acceleration data. So for these, we have incorporated 7 attenuation equation to find out the peak ground acceleration data for different faults. I'm showing just few of them. As I said that for we did this work not only for Northwest Himalayan fold and thrust belt, but some part of Pakistan as well. So there is a huge number of tables and data which the present time does not permit me to show. I'm just going to show that in this way we have presented our work in different publications. Now these are the seismic hazard curves, and seismic hazard curves. These are plotted for different return periods, and not only researchers in Pakistan, they usually take 50 years return period, but um, I use this software, and this software, the utilization of this software helps us to find out the peak ground acceleration for the larger span of uh, frequency of exceedance. Means we cover a large span or large duration for the estimation of peak ground accelerations. Once again, the same map, the same map. Um, Now, this is representing the. I'm going to just wind up. There are some few slides left. This one slide is showing uh, the part of Suleiman Kether fold and thrust belt, and along with Quetta transfer zone. And once again, we prepared a catalog for this area, and we plotted the earthquake on this map, and these earthquakes they are showing that strangely here this catalog is showing that there are major magnitude earthquake. They are more in numbers as compared to smaller size or moderate size earthquakes. So this another forecasting or prediction or another probability of occurrence of major earthquake other than Northwest Himalayan fold and thrust belt is we interpret or we say that in future a major earthquake if occurs other than Northwest Himalayan fold and thrust belt, then it will occur in this part of Pakistan, which is Suleiman Kirthar fold and thrust belt and Quetta transfer zone. We did hazard estimation as well for this part of area, and all those parameters and acceleration curves, and I'm not showing in this presentation because this work is under review and it is submitted to some journal. When once it is published, then it can be shared with all the researchers. But this is the result of our probabilistic seismic hazard assessment using Monte Carlo simulation for Suleiman and Kether fold and thrust belt and Quetta transfer zone. Now at the end, we then try to develop a new seismic hazard map of Pakistan, which is based upon the newly developed catalog of Northwest Himalayan fold and thrust belt and Suleiman Kirthar ranges and Quetta transfer zones, and we plotted it in contour form, and each contour is showing the PGA value. PGA value is in PGA value interval is taken as 0.02, and we can see that in Islamabad, near Islamabad, we are having 0.38 G PGA value, which is comparatively higher than the previously uh, developed model of hazard model of Pakistan. But this work is based, as I said earlier, that this work is based on MC or Monte Carlo simulation technique. So this is the most updated uh, hazard map of Pakistan, and this is also under review, and soon it will be published. And but I must say that this work is once again based upon the real-time, updated, authentic catalog. And uh, the other important thing is that we have not used the conventional technique which has been adopted all over the country by various researchers and by myself. At this time, we adopted a new approach, and this new approach is quite useful and more authentic as compared to conventional probabilistic seismic hazard technique. At the end, um, this is a list of some of our work which we did. Um, as you can see that um, Kasimjan Saab helped me a lot in publication, and you can see that we have um, worked on. I have worked with Zaire on Nepal earthquake, and with Kasimjan Saab, we published in different uh, journals like Natural Hazards and Journal of Seismology, which are leading journals of our field. And I must say that these are those journals which are which are very high ranking journals in our field, in the field of seismology. And as I said, that we have worked on Ziyarat earthquake, which occurred in 2008, and in which we introduced for the very first time the concept of duplet. So this work is very interesting, and I must say that everyone must read it and study it in order to work uh, on Ziyarat or Balochistan area. So this list is showing some of the work which is covering not only northwestern Himalayan fold and thrust belt, but other part of Pakistan as well. Um, so I'm it, and I'm really very grateful to all of you for bearing me for such a long time. Thank you very much.
Yeah, well, MonaLisa, this is Bob. I want to thank you for your very thorough presentation, and interesting to see the span of research that you and your colleagues are working on. I have a quick question. I just wanted to ask you about whether there are zoning for construction. In other words, are there regulations being implemented in the construction and architecture industries in Pakistan, resulting from the knowledge that you are providing of seismic hazard? Are there seismic requirements for the new buildings being built, for example, in Islamabad?
Yeah, well, your question is very interesting, and definitely this is the problem which we all are facing in Pakistan. Although we are working since 2005, and we are formulating different hazard maps for different areas of Pakistan. Even I and Kasmian Saab have recently published some of the work related to some parts of Pakistan. But unfortunately, implementation of these hazard zonation work is not very appropriate in Pakistan. So I think Kasmian Saab can address it more appropriately, because we are facing this problem that policymakers and government officials like NDMA and other institutes They actually there are so much researchers in Pakistan, and there are now so much publications related to hazard. They are themselves confused which approach and which zonation they use. So I think this is one of the issue which they are facing. And the second thing is that the implementation of these hazard parameters. Unfortunately, policymakers and government officials they are not caring much about the implementation of these the results of these donations. Kasimjan sir, you may explain further.
Well, I don't know about that, but all I can say that now they do have a building code in Pakistan, and let us hope that they ensure that large buildings are constructed according to the building code that they have developed. And you were a member of that committee. Thank you.
Well, very good. I have one more question, and then if anybody else has questions, please raise your hand or jump in. But I wanted to address that. You indicated there's a Kashmir Himalayan seismic gap. One of your maps early on indicated that there's a seismic gap, and is that tied to the high risk that you're mapping in the area north of Jhelum, north of Mangla?
Yeah, as I indicated that this seismic gap, which is observed in some of our work, and in most recently one of my MPhil student, which did his integrated approach, like he used geophysical studies, seismic data, seismological data, and field work. All these work they are clearly indicating that this seismic gap exists in northwest, and they can cause a severe damage to our strategic locations, especially Tarbela and Mangla. Because near Tarbela we are having Indus-Khoisan seismic zone, and near Mangla we are having Hazara Lord seismic zone, and on the surface we are having active Riyasi thrust. Yeah, yeah.
We have a question from Andrew Meach. Please open your mic and ask your question.
Hello, MonaLisa. Thank you very much for such a wide-ranging and comprehensive discussion. I really appreciated it. Could you just explain to me what the numbers are in the focal mechanisms that you show? Are those the depth of the event? I noticed there were little numbers in all the beach balls.
Yeah. Actually, the numbers they are actually showing the total number of fault plane solutions, total number of earthquakes for which fault plane solution data was available. So one thing is that the number they are only indicating the total number of the earthquakes which are incorporated for the formulation of fault plane solution. And the second thing is that these fault plane solutions, the arrows and numbers, they are showing the location of those fault plane solutions on those specific fault map, that where they were actually occurred, and uh, those earthquakes whose fault plane solutions were carried out, they are actually showing their location, those arrows, and the numbers they are showing the total number of earthquakes which are incorporated for fault plane solutions.
I see. What are the sort of typical depth ranges of some of those earthquakes? Like, for example, in the area around Islamabad and farther to the north.
Yeah, Andrew, very interesting question. Thanks for indicating this, because I have not mentioned it in any of my slide. So by answering your question, I must say that Your question is very informative. The depth of these earthquakes, whose fault plane solutions have been carried out, is very shallow, especially near Islamabad. As I said, that they are all which are occurring near Islamabad and Tarbela. They are occurring at the depth of 10 kilometer, 8 to 10 kilometers.
Mm.
So Hazara Lower seismic zone is also lying at the same depth as indicated by Sieber and Abuster in their research. So our work, I have discussed this work with Bob when we have interaction. Bob Yeats, when we having interaction with Bob Yeats, and we were planning to publish our fault plane solution data. I, Kasim Jan Saab, and Bob Yeats, by correlating fault plane solution data with the geological field studies. So in during that discussion through emails, we concluded that Hazara Lode seismic zone is actually can be the causative source of earthquake in Islamabad, not the
Yeah.
surface faults.
Thank you.
Yeah, thank you very much.
The next question is from Professor Qasim Jan. Sir, please ask your question.
Thank you. This is not a question specific. First of all, I would like to compliment Dr. MonaLisa for a very nice presentation and full of new information. This is good for science, and we owe it to her.
My pleasure.
My question is not. Pardon me? Yeah. My question is not specifically addressed to the speaker, but it's a general question, and that is, Pakistanis have been made to believe that Kalabagh Dam would solve a lot of our problems as far as irrigation and water storage is concerned. And some people very seriously in the government community, some very senior engineers, for example, they believe that we should construct the Kalabagh Dam as soon as we can. I have some technical fears. There is political controversy on the Kalabagh Dam between various provinces, particularly between Sindh and Punjab, which I am not addressing. But my question specifically is that if we have active tectonics going on in Kalabagh, and there is also a fairly thick layer of salt which extends for tens of kilometers to the north and perhaps also to the south. So would it be a safe site for construction of a big dam? Wouldn't there be a danger of salt tectonics, salt diapirism, ultimately disrupting the structure of the dam? Thank you.
Well, I think, Qasim, just to answer in general, the challenges of constructing large dams in Pakistan generally is a subject of risk because, for example, both Tarbela and Mangla are in areas of seismic hazard of one type or another. And I think that as you mentioned, Kalabagh, of course, the Kalabagh fault zone is nearby. The distribution of evaporites is not precisely known, I think, in the subsurface, and it would be possible that there would be some salt remobilization or dissolution once you put a large reservoir in that area. And I think these are engineering questions that require, detailed studies, and at some level, the nation will have to balance the risks of developing water storage in zones that are challenging. And as you look at the lifespan of the Tarbela Dam in particular, which is, as you know, I'm not sure what the total lifespan is, but it's filling up with sediment slowly. And I think that there is a tremendous need for water storage and both for irrigation and for hydroelectric purposes. And I think that it may be that it'll be necessary to take some risks in terms of providing the resources to the nation.
Thank you. Thank
Yeah.
you, Bob.
And so I think with this, we've had a wonderful morning on your side and an evening on our side. Thank you very much, MonaLisa, for your presentation, and it complements nicely the work that Andrew Miggs presented earlier and other studies. And I think that the interface between the earth sciences, geology, and engineering and the public need, we've just sort of underlined that a little bit here right at the end. But I think that this is one of the great challenges that we face worldwide. I mean, there's worldwide water challenges in every country, and I think that as we go forward, we need additional data, and the work that you're doing, MonaLisa, with your colleagues at the Quaid-i-Azam University is a wonderful contribution to understanding. And I'm we'll have to hope that the scientific data can be incorporated into public policy planning as we go forward. I'd like to thank everybody for your participation, and I look forward to seeing you next week when we have the talk by Turi Serling from the University of Utah.
Yeah, Bob, I must say I'm very grateful to you for providing me this venue to present my work, and I'm really very happy because not only a presentation is a big honor for me, but also meeting with Andrew and you and Kasimjan Saab, although he's in Islamabad, but we don't have a frequent meeting. We only work on email due to this COVID. But I must say that I'm really very grateful to all of you by listening to me and by allowing me to present my work. Thank you very much.
Yeah. Well, thank you very much for your hard work. So
Thank you.
Thank you.
Good night, everybody.
Yep. Thank you all.
Goodbye.
Yep. Pirmalenge.
Bye-bye.
Recording बंद
All right, Azam.